Here is a test problem on inverse of the quadratic function. Given f of x equals to half of x minus 1 whole square minus 2, find and graph f inverse. Restrict the domain of the function and state the domain and range of inverse relation such that f inverse is a function. So try to understand the question, pause the video, solve it, and then look into my suggestions. Now as you can see, what we should do is, we should first find the inverse of this function. We know f of x is equals to half of x minus 1 whole square minus 2. To find inverse, we'll interchange x and y. So we can write this as x equals to half of y minus 1 whole square minus 2. And now we'll solve for y. So we get x plus 2 and then multiply by 2, right? So let's do it in the next step. Times y minus 1 whole square. Now we can multiply by 2 and get x plus 2 equals to y minus 1 whole square. We can square root now, which is 2x plus 2. Square root, whenever you square root, you have to write plus and minus, which is y minus 1. And now you get y equals to, take 1 on this side, 1 plus minus square root of 2 times x plus 2 within square root. So that gives you inverse of a function. And let me write inverse of the function right here so that we can sketch it later. So we have f inverse as equals to 1 plus minus square root of 2 times x plus 2 within square root, right? So that is the inverse of our function. Now the question is, restrict the domain of the function and state domain and range of inverse of the function. Now, as you know, inverse of a quadratic function will never be a function. So if a quadratic function is kind of like this, then the inverse is like this. Quadratic function fails horizontal line test and therefore inverse fails the vertical test, correct? But you can restrict your function, the quadratic function, so that its inverse can be a function. So the best point to restrict domain is from the vertex itself. So the vertex is at x equals to 1. So what we can consider it, let us restrict it to x greater than equal to 1. If we restrict this, then the inverse will be a function. Now if you restrict this, do you know what effect will be seen on inverse of the function? You'll have inverse function with only positive sign since you are considering x greater than equal to 1. Remember that part, right? So basically, you'll have a function like earlier it was like full parabola. Now you're only considering 1/2 of the parabola, right? So you're considering x greater than equal to 1, and in this function, y will be greater than, because this is opening upwards, y will be greater than equals to minus 2, right? That is your range, right? Minus 2. And in the inverse function of your restricted function, x and y are going to switch. Do you see that? So in this function, you have to choose one plus sign since you have restricted your domain for the function. And you'll find that the domain and range of inverse function will be kind of flipped. Do you see that? That means your x value will be greater than equal to minus 2, which you can see from here also. X has to be greater than equal to minus 2. Otherwise, this function inside will be negative. Do you see that? If x is minus 2, it is 0. And if it is less than minus 2, then it is negative. So it has to be on the right side of minus 2. So as you can see here, for the restricted function, the domain will be x is greater than equals to minus 2, right? That is going to be the domain. And of course, we'll write where x belongs to real numbers and put them in curly brackets. So that's the domain for the function. And as far as the range of the function is concerned, range will be y greater than equal to 1. So it will be y belongs to real numbers so that y is greater than equal to 1. So that is going to be the range for our inverse function. Well, now we already have the equation here. I'd like you to sketch the function yourself out there, and it has to be x greater than -2. That means it will be something like this, correct? So sketch it and then move on to the next question. Thank you and all the best.